Seems to be a smaller crowd today. Any questions? Yes. On 12a? Okay, let me look. Oh, it's getting the height at that point. So, yeah, let me talk a little bit about 12a, because there's a bit of a complexity to it. So, we have this rectangular terrain. And now we're breaking it up into some number of rows and columns. So in this example, we have 4 rows and 6 columns. And so we're kind of assuming that the height is reasonably constant within any one of these little subrectangles in here. And now one can call the set method. So let's actually put some specific numbers here, so that'll make it easier for me to explain it. Let's say that horizontally it goes from 100 to, and I'll just make this to make my math easy, to 700. And vertically it goes from 200 to 600. And now let's say I call set by saying terrain.set. And now I've measured that for whatever reason over here at 310 and 405. Sorry. I've measured the height is 50. So I would call set like that. So now let's see which of the rectangles is it. So that would be if I just write the intermediate numbers in here as well. Here we have 300, 400, 500, 200, 300. So we have the, did I mess up the x and the y's? No, that's okay. So so these are this is the x and this is the y. So x goes in this direction and y goes in this direction. And so now x is 310, that means it's here. Y is 405, that means here. So that means we're looking at this point here, which means we're looking at this particular rectangle here. And we're now saying that we have measured that this thing here has height 50. Now, if later you ask about any other point that sits in here, so for example, t.get 320, 410, then that should also return 50. Because it's still inside the same rectangle. So the assumption that the height is constant within each of the rectangles. Well, the internal data structure is going to be a two-dimensional array of numbers. And yeah, that internal data structure could be used for anything. But so here it's going to be used to store the heights of each of the rectangles. So clearly the internal data structure is an array of doubles, a two-dimensional array of doubles. And it's going to have some number of rows and columns. Weren't those given in the constructor? Yes, they are. So you know it's going to be a new double rows and columns. So in our case, we had, what, 4 rows and 6 columns. What's that? They're supposed to be brackets, sloppy brackets. Yes. So that stores the values. And so now there's a problem here that the values for x and y can be in a continuum between the minimum and the maximum. But the row and column indexes, they're integers between some very finite range, 0, 1, 2, 3, or 0, 1, 2, 3, 4, 5. And so one needs to figure out how to map that continuous range of x's to the number of rows, and the same thing for the columns. So any x value between, what are the x and y's integers or doubles? No, they're doubles here. So any x between 100 inclusive and 200 exclusive should map to which column index? 0, right? It's the initial column, the 0th column. And any between 600 inclusive and 700 exclusive should map to which column index?
6.
Okay, this is column 0, column 1, 5, right? 2, 3, 4, 5. And if you have 6 columns, the last column has index 5. So how does one do that? So let's do this again slowly here. I think I need a new sheet. So when x is between 100 and 200, and I'll use the mathematical notation here, where the bracket means including and the parenthesis means excluding, then I want my column index to be 0. If it's between 200 and 300, I want the column index to be 1, and so on. If it's between 500 and 600, I want my column index to be 5. And so, and this was an example where I had x min was 100, x max is 600, and the number of columns. No, x min was, sorry, from 600 to 700. 600 to 700, and x max was 700, and the number of columns is 6. So the first thing to figure out is what is the width of each of the little rectangles. So I have my big area here. I've divided it into 6 columns. Side height, here from x. Many. Divided into 6 columns. I know this entire big thing here is, okay, how long is it?
6.
In x's, not in columns. It's 600. How does he know? The math genius in front. How does he know it's 600? Okay, superior powers have been bestowed to him, and he does not. What is it? How do you know? How does he know? So that's actually the harder part. How do you know that? So I was going to try to get to that. How does one know that the entire rectangle, the big rectangle, is 600 units wide?
Actually, it's like right under 6. It's not inclusive.
It's still the same. Okay, that's a good question to watch. I come in a minute. So it's x max minus x min. The width of a rectangle is the max, the widest, the rightmost minus the leftmost coordinate. So, I mean, we have to come up with an equation that works for any cases, not just for 100 and 700. So x max minus x min gives you the width of the entire rectangle. So how do you know the width of each column? So the whole thing is 600. We have 6 columns. How wide is every column? How do you know? Yeah, so it's the width divided by the number of columns. Okay. So that way, you can always compute the column width. So now you know the width of every single column, which is potentially useful. So each of these here is now 100 units wide. But that's not, well, is that useful? Yes, useful. So now let's say we have a particular point, and I'll just choose one at random. A particular x, let's say 314. And I want to know in which column does it fall. Right, as it happens, this is 100, 200, 300, it's going to be sitting somewhere here. And so how do you know that? And here's what you do. So you compute x minus x min. Which in our case would be what? Would be 214. And you divide that by the by the column width. So 214 divided by 100 is 2. You discard the remainder. In mathematical notation, we would write it like that. In Java, you would write parentheses int. And that's the column number. So let me put this. Let me put this into BlueJ really quick so it becomes clear how that looks like. Oh, actually, didn't we get it? No, that was so cruel. I meant to give you the starter. Okay, so as an aside, so we're getting this constructor with all of this data here, and so that's x min, y min, x max, y max rows and columns, default height. Well, I know what to do with the rows and columns. As I said before, we need to store those various heights. And for sure I'll need them later, so that's an instance variable. Double rows, columns. And at some later point, namely when I implement the get and set methods, I will need to know xmin, xmax, because I'm going to have to implement this math here. So I need to hang on to them. Right now they are just variables here in the constructor. In order to hang on to them, I need to make them into instance variables. So notice how I use the this dot here. I'm too lazy to come up with new names for them. Xmin and Xmax seem to be pretty good names for them. And that's also how they happen to be named in the constructor. And so now I have the instance variable xmin and the parameter variable xmin of the constructor. I'm too lazy to rename either one of them. And so I use the this dot to disambiguate. This dot xmin is the instance variable. The xmin without is the parameter in the constructor. You don't like this? That's okay. You can rename one or the other. So you could rename the variable, the instance variable. Some people do that. They would call it my xmin or some such thing. Or you could rename the instance variable, sorry, the local variable here and call it like an xmin or some such thing. But that seems like a lot of trouble for a little gain. So I'm just using the this dot trick. So that way I remember them in perpetuity. You do the same thing for ymin, ymax, and so on. Do you need to remember the number of rows in the same way? So should I go ahead and say private int rows? Yes?
I think that xmin and xmax should be
Oh, thank you. Thank you. Absolutely. Yeah. Okay. Should I remember the number of rows in an instance variable? Yes or no? I don't need to. Why don't I need to? Yes, so I can calculate it from heights. I can ask heights.length, that's the number of rows. Remember, heights.length is the number of rows. Heights bracket 0.length is the number of columns. So when I have an array, I can always ask it how long it is. And if I have a two-dimensional array, I can ask it how many rows and columns it has. I don't need to remember that. And in that case, I shouldn't remember. Because remember, taxes for instance variables are going to go up January 1st. So we should be in the habit of not having more than we need to. So in general, you never want to remember something that you can compute easily, because whenever you have two sources of information for the same thing, there's always the modest chance that they get out of sync in some way. And so it's always best to have a single variable, a single source of that truth. And in our case, that would be the variable heights, which perfectly well knows the number of rows. All right. The number of columns I don't need to remember in the same way. The default height I should do something with. What I really should be doing over here is I should fill this 2D array with default height. That's a simple nested loop that you can find in the book. All right. Now let me look at the set method. So public. So I think that's what someone asked. Did someone ask set or get? I don't remember. Get. Okay, I'll write get. Double X. Well, that was easy. Except it's now still in pseudocode, and I have to still implement how to actually get the row for y and the column for x. Notice, by the way, that the rows and columns are flipped with respect to x and y, and that's always true when you deal with two-dimensional arrays. Let me make a quick sketch here, because it's something that people find confusing in general. So here's my two-dimensional array, and the rows go this way, and the columns go this way. Right, this would be like row 4, column 2. And in a coordinate system, x's go this way, and y's go, well, at least in a graphical system, y's go down. And so the x's and the columns go in the same direction, and the y's and the rows go in the same direction. That's why over here you find this seemingly illogical that, compute the rows from the y's. So I just had this formula on how to compute the column for the x. So that sounds like a great helper function. No, it's an int. Right, a column is an integer. Okay, so how did this go? It said, okay, compute the width equals x max minus x min. Compute the column width as the width of the number of columns. Compute the column. Well, that's what I need to return. So that's what? X min over the column width. So I just typed in the math in this way. That's just one little thing here. The number of columns I actually don't have. That is heights 0.length. Maybe that's not very easy to read, so we might want to actually leave the variable in here and this way it would be a little easier to read. So with that little helper thing here, I can then just write column for x here. Well, what do you do for the rows? You can't just call column for, because the numbers are going to be different, right? The rows depend on y min and y max and the number of rows. But otherwise, the math has got to be the same, right? You have y max minus y min gives you the height of the thing here. You have the number of rows is the height, the row width, or row height, I should say, is the total height divided by the number of rows. And then the other formula is going to be the same one. Now, as a minor aside, if you find, this kind of formula is something that one needs all the time. Once every few weeks, I have to kind of reinvent this formula, because it just happens so often that you need to do this kind of interpolation. And the way that I found it a little bit easier to remember is as follows. So when you have a line that goes from x min to x max, and now you have some particular point x in here, it's often really useful to know what percentage or what fraction is this distance. And that one is easy enough to compute. It is x minus x min over x max minus x min. And I find it pretty easy to remember. The x minus over x min over x max minus x min has a certain symmetry. You subtract the x min. And so if you look at this expression, and what happens when x equals x min, when you're all the way at the end, then you have x min minus x min, which is 0, which is how it should be. Now, when x is x max, then you have x max minus x min over x max minus x min, which is 1. So this expression ranges from 0 to 1 as x ranges from one end to the other. And that's just a super useful expression in many cases. So now I want to know in which column I am. So in that case, what I simply do is I take this expression, multiply it by the number of columns, and now I have an expression that is between 0 and 6 as x ranges from one end to the other. And that is 0 inclusive and 6 exclusive, because I said we're never actually going to hit x max. I made it so that those rectangles are open on this side. And so that's maybe another way of getting to the same equation, but one that I personally find pretty easy to remember. Now I still have to take the integer part of it, of course, to get rid of the fractional part. All right. So in many, many cases, this expression here, x minus x min over x max minus x min, is just really useful to know. So I'm not going to change it here in the interest of time, but I easily could. All right. More questions about this or any other homework? Okay. Let's go on with the lecture then. So the lecture is about static variables and static methods. And this is something we've seen static, of course, for a long time. Public static void main is a static method. And so today the meaning of static shall be revealed. Let's start with static variables. Once in a blue moon it happens that you have a value that you want to store so that all methods of a class can access it. But that that variable doesn't belong to any particular object. So in this example here, I want to, in the constructor of the bank account class, I want to give account numbers that are consecutive. The first account is going to be account number 1000, because you would never want to join a bank where you get account number 1. But maybe 1001 is not so bad. So we'll start with 1001. Then each time that the constructor gets called again, we will increment the last assigned number and assign whatever that is now to the account number of the object. So here you see the code for that. In the constructor, we increment the last assigned number, and then the account number of the object that we're currently constructing then gets to be that number. That way all objects get consecutive account numbers, 1001, 1002, 1003, and so on. Now, what is the state of each account? Each account, of course, has an account number, and it has a balance. Those are the instance variables that you see here. What about last assigned number? I can't store last assigned number in any individual account, because then I wouldn't be able to access it from the constructor of the next account. So there's only a single value for all bank accounts of whatever the last assigned number was. There's unlike the account numbers and the balances, which vary from one account to the other. So it's kind of like a globally accessible variable. And in Java, one calls these globally accessible variables static. When I say globally accessible, I mean accessible by any bank account method. So static means only make a single variable, make it shared amongst all of the bank account objects, amongst all of the objects of the same class. And don't make a separate instance variable for every object. So every once in a while that's useful. Here you've seen a pretty useful way of doing it. So over here I have this picture here where you can see these three variables. You can see each of them has balance and account number in the object as instance variables, and there's only a single last assigned number, not one per object. So that's a useful picture to keep in mind. And it doesn't seem like an incredibly complicated feature. So why is it called static? It's called static because it was called static in C++. Why was it called static in C++? Because they ran out of keywords in C++. Static was used for a totally unrelated purpose already in C++, and they figured they could use it in this situation without creating ambiguity. That's a pretty dumb way of naming something, but that's exactly what they did. They could have used while, and it would have worked just as well. So when you see static, you just have to remember static doesn't mean static. Static means shared. Shared would have been a great name for this. A private shared int. It's shared amongst all objects of the class. So why didn't Java, when it was first created, change this, use shared instead of static? Because they were stupid and short-sighted. Because they felt that the minor convenience of a few 100,000 C++ programmers outweighed pestering millions and millions of future programmers. If you ever design your own programming language, and it would be a really good idea if you worried more about the many, many people who will want to learn the language in the future rather than the few people who have learned some inferior language in the past and want to have an easy transition. But sadly, that lesson was lost on the designers of the otherwise very fine Java language. So you just now have to remember static means shared in Javanese. All right, so it's a shared variable. All objects have access to that single variable. There are very few times that you actually need these shared variables. There was one example in one of the labs that unfortunately was timed well before the lecture, where you had a random number generator that was shared among multiple objects. And a random number generator, that's as good an example as it gets, because there's really no good reason to have one random number generator per object. Number one, it's expensive. And number two, it's actually not as random. It turns out that these random number generators are very well tuned that if you have a single generator and you keep pulling numbers from it, those numbers are pretty random. But there's no guarantee what happens if you have 1,000 random number generators that all operate in parallel. They may or may not give you an overall very random sequence. So it's actually a good idea to share a random number generator amongst multiple objects. And so that's really a great example. Another example for where you want to share something is when you have a constant value, like pi is a shared or static variable in the math class. Or you might want to have like a default interest rate or a default starting balance or some such thing. That's a constant. And constants always make sense to share because they never get modified. So if something never changes, you might as well share it amongst all objects. So you would use static variables for this very rare situation where you need a shared counter or a shared resource like a random number generator, or when you have a shared constant. And yeah, like here we have an overdraft fee. That's as a constant. That's a good idea. If you know that the overdraft fee is going to be the same for all accounts, then why not share it? Of what? Oh, okay. So let's decouple that here. So we have 4 different modifiers. Double is clear; it's a double. Final means it's a constant. Yeah. So for reasons beyond human understanding, instead of using the keyword const, which would indicate to you that it's a constant, they use the keyword final. And whatever. That's not good. Final is a constant. Static means shared. So final just means you can't change it. What a constant is a variable whose contents you cannot change. I mean, we've had constants all over the place before, except when they were local to a single method, we would just say final double. So static means it's shared, and public means that actually other classes can also access it. But when another class accesses it, they can't just say overdraft fee. They have to say bank account dot overdraft fee. Just like whenever you wanted to use math.py, you had to say math.py. You couldn't just use pi. So in general, one wants to minimize the use of static variables. They're not considered great design. Particularly, you want to minimize the number of public static variables that you have. And I don't think I can't think of any public static variable like in the entire SDK, in the Java JDK. So it's a pretty rare thing that you're not normally going to encounter. And the reason for that is that in other programming languages where there are global variables that can be accessed from anywhere, it was noted that programmers start to use those in really unpredictable fashion. One method might read from it, another method might stick a new value in it, and no one really knows who made the last modification. And as your program gets large, they're very hard to control. In Java, there's not much of a danger for this happening if you follow the normal class layout, so I'm not going to belabor it at humongous detail. Okay, I can't do this one yet. I messed up the order. Okay, where's static methods? Okay, for some reason I lost the slide on static methods, so this is really great. Okay, so I'll have to do that by hand. Okay, sorry about that. So so we have these methods that are declared static, such as public static void main. There's an example of, in the book, where we have a class numeric, and it has a method public static double %, and it takes an amount and a rate. And it returns the amount times the rate over 100. And you might call it by saying interest equals numeric % of balance and rate. So when you look at this method here, it's a very simple method, but it may be useful to have it because it makes the code a little bit easier to read. When you look down here where it says numeric.%, you know what the interest computation is. It computes the percentage of the balance by that interest rate. So it's somewhat self-documenting. Now, it's a static method because static means it does not operate on objects. So I should have said that. Static means it doesn't operate on objects. It doesn't have anything to do with shared or anything. It simply means it doesn't operate on objects. So the % method doesn't operate on objects. Why not? Why don't I make a normal method? It only deals with numbers, and in Java, numbers are not objects, so my hands are tied. So this is one reason why you might want to use a static method, that you must have a method that operates on things that are not objects.
So pretty much just integers, doubles,
Integers, doubles, arrays. Arrays are not objects. Well, I shouldn't say that. Arrays are objects, but you're not allowed to add in new methods. Now, that's another reason why sometimes you use a static method. You might be operating on some object that you don't own, where you're not allowed to stick in your own method. So, for example, you might want to do something with rectangles. You might want to, oh, I don't know, double the size of a rectangle, inflate it by a factor of 2 or inflate it by a factor of n. And that's not something that you can do by adding a method to the rectangle class. Why not? You'd have to write a whole new rectangle class because you don't own the rectangle class. So when you need to operate on objects that you don't own, then also you can't write your own regular methods. Then you would write a static method where the first parameter is the thing that you want to manipulate. So ever so often you have the situation that you can't write a regular method, and the static methods give you this escape hatch. So a static method operates on whatever you want to operate on. It just is not a part of, it doesn't operate on the this variable in the normal way. So, and what's commonly done is you have two places where you might put a static method. The case that you've seen here is very common. You have a utility class, and you just dump a bunch of static methods in it. And then when you want to retrieve one, you have to prefix it by the name of the utility class. The other thing that you can do is if you have a method that is part of your where you just need to do some auxiliary computation in your regular old class, you can just put it in there, and the static indicates that it's just an auxiliary that only needs numbers as its inputs. So, for example, that's why I left this open here. Look at that column for method. That looks just like one of those methods that has nothing to do with my instance variables. It just takes, well, does it? Well, let's find out. Can I put static over here? It just takes a number, right? Ah, so he's paying attention. Good. So x max and x min are instance variables, and so this would not compile. Let's try it. Well, yeah. Now it says here, the non-static variable heights cannot be referenced from a static context. That means in plain English that a static method does not operate on the current object, so it can't access any instance variables. And here I'm trying to access an instance variable. So here I was overreaching with the static. But there are situations where having a static helper method in one of these things works just fine. So for example, in homework 12a, let's see if I can find it. Is it 12a? No, in homework 12b. I want you to write a class grids that contains these three static methods. So let's look at the first one here, the count non-zero neighbors. I could swear I wrote this thing already. Let's see if I can find it. Come on, Blue Jay. I didn't? Okay. guess they're not. Maybe I'll write if I have some time. So, so count non-zero neighbors. What does it get? It gets an integer, a two-dimensional array grid. So it gets a grid of numbers. And it gets a row and column. Let's say it gets this position. And then it's supposed to look around in the 8 positions surrounding it. And it's supposed to count how many of these are not 0. And it gets all of the information that it needs as explicit parameters. The grid, the row, and the column. It does not need any instance variables to carry out its job. And it's static. So in fact, this grids class is going to have no instance variables at all. It's just the holder for this utility method and the next two utility methods. Yes?
So those classes that you put on the raise 1 and raise 2, you also put those as static?
Oh, excellent question. Let's have a look. So his question is, what about homework 11? Could we have also used static methods?
Raise 1 and raise 2.
Yes. So look at this. Is up then down could perfectly well have been static, right? Because it doesn't use anything other than what's in the values. And then it's actually good form to declare it as static because that tells the reader, hey, this doesn't use anything other than the parameters that are passed in. Now, the only reason I didn't do it at the time was, why? Because you didn't have static methods yet. So there's no other reason. So generally, you would want to declare this thing as static. Same here. Let's look at arrays 2. Same thing. Right? None of these methods here needed anything other than the stuff that was passed in. And here with negatives first, it's also the same thing. And here in this situation here, could I make this as a method of array list of integer? No, because I don't own that class. So even though it's a class, not a primitive type, I still need to make a static method. Yes?
So if your class has no instance variables whatsoever, do you even need to put a constructor in?
No, you don't. And in fact, the arrays 2 class didn't have a constructor.
Yeah, I put it.
Oh, someone remind me to post the solution. I forgot.
I put it in just in case they didn't.
No, there's no harm done in doing that. So actually, let me do that in a demo program here, because there's another point that I want to make. What's this, lecture 23? So I want to do something with that percent off. Times 800. Okay, so let's say today is Cyber Monday, so we'll give a generous discount. 30%. So I'll write a little program that computes and prints out the savings that I'm getting today. So let me compile that. Oh, well, and I didn't mean void, I meant double. Thank you. Compile that. And now I'm getting this error message that says, I can't call the non-static method % from main. Why? Yeah, main is static. Why the heck is main static? Yeah, no one's ever made an object of the class lecture 23. And it's a bit of a chicken and egg problem. Who could have made that object of the class lecture 23? It would have had to be in some kind of code. And so the computation has to start somewhere before a single object has ever been created. And so the job of main is to kick off the program. When the program first is started, there isn't a single object. And so generally in a larger program, the job of main is to create a bunch of objects and to start calling a method on them and to leave the static world. But here this program was really simple, so I didn't have any objects that I wanted to create, and instead I just want to call this method here. So I can now declare this method as static, and now the class compiles, and let me run it. And it gives me an answer. I would have saved almost $6, so whatever. So if you want to call a method from main and you don't want to call it on an object, then you use static here. And so in the few remaining homeworks, the testers, if the tester needs to call another method, it'll do that. What you've seen me do up to this point here is I've artificially made an object. So if you looked at the tester for homework 11, it had stuff like this, where I artificially made an object of type arrays1, arrays2, even though I wasn't particularly interested in that object, it has nothing inside, but that way I could call its non-static methods. So over here, I can simplify my life. I can simply say, well, this is a static method. All right, so that brings me to my clicker question.
So basically, you could make a tester and it calls, it has a method and it calls it.
Yeah, or like if I wanted to call the other methods, I'll just write it in here because I could call something like arrays 2 dot, what was it, up then down, without having to make an arrays 2 object. I can just call the method like that. So the key is without having to make that dummy object. All right, so here's finally my clicker question, I hope. Oh. So look at what we've just done. We've found a way of completely avoiding those pesky objects. And so the recipe is, what if we simply, instead of dealing with multiple classes, we could put all the code that we want to write into a single class and call it my program. We make all methods and variables static. The static methods can call other static methods. That's fine. The static methods can access the static variables. Main can call them all. So that seems like a great plan to completely get away from the complexity of objects and classes and all of that crud. So what do you think? Is it actually workable? can you program without objects and classes? Or do you think it's not going to work at all for whatever this reason is? Or if it does work, will it make programs simpler, or will it make programs harder to understand? So maybe that's a bit of a judgment call. So let me put up that question and see what you think. Well, that question is meeting with some enthusiasm here. All right, so let's see. So I guess the rationale for number one, which was the choice of 11% of the popular vote, I guess the rationale would be, well, if you could avoid using objects and classes, why the heck did we cover them so much? But actually, the truth is you can avoid objects and classes, and before people programmed in Java or C++, they programmed in C where there were no objects and classes. So it won't work. You can't call other static methods from main. Well, we just talked about that you can't call non-static methods from main, so that's nonsense. But it did actually attract, well, 2 votes. Okay, well, that doesn't mean it. No, 9 votes. Okay, well, what can I say? Those 9 people, think about what I just said. All right, so it will work, but it will make programs simpler to understand. And so a good percentage of people said yes, and then people said it'll make them harder to understand. So actually, truth be told, for the kind of simple programs that we're writing in 46A, it really would be simpler to just use static methods. Because the kinds of programs that you've been writing were what, like 50 lines long or so? They would easily fit into a single method and into a single class. You would just make one class, you would put them in there, and I could have reformulated all of these loop questions, all of the array questions in a way where you could simply do that. And there are some instructors who prefer teaching that way, who prefer first teaching everything with static methods, teaching loops, teaching arrays, and then after the students are all done with that, then one starts teaching objects and classes. On the theory that you have to learn both anyway, but objects and classes are clearly not simple concepts, so why not teach them a little bit later? For larger programs, it doesn't work. For larger programs, when you have hundreds or thousands or tens or 100,000 lines of code, putting them all into one class would clearly be counterproductive. And even if you distribute them as static methods over multiple classes, it would make your program hard to read. And that was exactly why objects were invented in the first place. Objects were invented because people were frustrated with programs that had hundreds and thousands of lines of code that were difficult to manage, where like any one of those lines could have updated a bunch of global variables, and you never knew which one it was. So objects and classes were invented to structure programs, to clump them into related activities. Each class is responsible for one thing and only one thing. And so it really does make sense to use objects and classes in large programs. So the reason that in this course we're starting with objects and classes early is twofold. Even though for CS1 it undoubtedly makes some programs harder to write than they would be just with static methods. Number one is that many people have found that if you first teach static methods and then teach objects and classes, large percentages of students are resistant to using objects and classes because they already know another way of solving the problem. And because for the students, they don't, until they're in their senior year or in their first year on the job, they don't actually get to the point where objects and classes are clearly and demonstrably superior. You know, they might write 1,000 lines of code in the largest program in college. Well, you can still do that without objects and classes. And so those students will just stubbornly stick to static methods as the hammer with which to attack all problems. Whereas when you teach objects and classes first, then that's the way that's going to scale to much larger programs. And then students, that's the hammer that they learn first, and that's the one that they use for everything. So that's one of the reasons. The other reasons we do it is that it's a bit of an equalizer for those people who've had programming in high school. Very few people in high school learn effectively to use objects and classes. And by starting with that in week 2 and week 3 in 46A, it doesn't give them quite as much of an unfair advantage. They too have to learn new stuff. And so, particularly in the labs, that's been very noticeable. So that was just the reason why we do the things in this way. But yes, you could ditch all objects and classes, and it would work beautifully for small programs. All right, a couple more technical things. Scope. So we say the scope of a variable is the part of the program where it is defined. So let's look at some of the variables over here, like the variable r here. Its scope goes from the point of definition until the end of the method. It's a local variable, and that's how local variables work. Same one here. This r goes from here to the end of the method. This a here goes from here till the end of the method. So you can see that the scope of A is a little bit smaller than the scope of R, which means that you can use the R over here, but I couldn't have used the A over here. It wasn't yet defined. That's pretty obvious. Notice you can have variables with the same name as long as their scopes are disjoint. Over here, this R here goes until here, and I have another one also called R here, not even the same type, and the scopes are disjoint, and so that's fine. It's probably something that you've done before. You've had local variables with the same name in different methods, and you never gave it much thought. So, on the other hand, you can't have scopes that do overlap. Here I have a rectangle R. It's a local variable. Its scope goes all the way here, and I cannot inside here define another variable R. So the R and the R collide here because their scopes overlap. I can do it as long as they are disjoint. Like here I have an R in this block, here I have an R in that block, and that's okay. As again, something that seems pretty obvious, but there are other programming languages that should remain unnamed, such as C and C++, where this is perfectly legal. And in this case here, this little in this local scope here, this R shadows the other one. So whenever you say R in this block, it means the double. Whenever you say R anywhere else, it means the rectangle. And it's a confusing situation that's never really necessary. You could always give different names to the two. And so for that reason, in Java, that's outlawed. And again, it's not something that you would have thought about much. If you, by accident, tried this, the compiler would have told you you can't redefine the variable in the same function or in the same method. Now, on the other hand, when you have class and local scope, you can have this shadowing phenomenon. So over here, I have an instance variable, and over here I have a local variable with the same name, and that is legal. Now, you might say that's a little bit unfortunate, because that is clearly room for error. This is a very common beginner's error, that people hide the instance variable by using the local variable. And so you can always disambiguate with this. This dot means the instance. Without the this dot, it means the local variable. And I really think that the only reason that they left that feature in place is the constructor trick that I've had at the beginning of the lecture, where you don't want to come up with different names for the local variable and the instance variable. I can't really think of any other reason on why you would want to have the same name in a local variable as an instance variable. Yes? Well, there's two different issues. One is the language designers said overlapping scopes of local variables we outlaw. We don't want it. We think it's confusing. And I said that's a good decision because it reduces programmer error. Now, they could have also decided to say we're also going to outlaw it for the overlap between local variables and instance variables. They chose not to do it, and I believe the reason is that they wanted us to be able to do this particular thing. I can't think of any other reason why being allowed to do this really adds a lot of value. And it does, once in a while, create a confusing situation. Now then there's the other question that says, should you or should you not always put the this dot? Here we have to put it, because otherwise it would be ambiguous. But in many, many other methods, we wouldn't have to do it. Like over here, I could say name, or I could say this dot name, and I would either way mean the same thing because there was no ambiguity. There are some people who nevertheless like to put this dot in front of every single instance variable. So let me demonstrate that. So where is it? Here. Over here, they would say this dot heights, this dot xmax, this dot xmin, and so when you look at it, you'll see it's now totally obvious which ones are the instance variables and which ones are the local variables. And that's actually kind of nice. Oh, over here, they would call this dot column 4, and you could totally see that column 4 is called on the implicit parameter. And if you like that, if you think that it helps you understand your own programs, by all means, go for it. There's nothing at all evil about it. And many times I wish that I could just recommend in the textbook for people to do that. But whenever I try, there are other reviewers who say, that looks weird. And you can't fight that looks weird. But by all means, if it looks good and natural to you, I think it's a very useful trick to remember the difference between instance variables and local variables. I mentioned that once before, but at the time, almost all the variables that we had were instance variables because we were so object happy. And then we moved away from objects a little bit because we did all the loops and arrays. And now that we're coming back, it might be, you might think that this is a good way for you to master that distinction. Oh, and over here, of course, it would be this dot heights, because it's an instance variable. So ponder that and see if you like that. Okay, I don't think I'm going to do this, and I'm not going to get to packages. And we'll just have to wait for next semester to do that. All right, that's all I got for today. So you have plenty of homework. This homework is reasonably hard, so spend a lot of time on it. I saw several reports on Piazza where people said, I just ran out of time. And so that means you should start early on this one. This one is hard. The next one is also hard. All right.